Hi, welcome to the session on proportional intercept theorem. So we're going to quickly examine the theorem, which states if a line is drawn parallel to one side of a triangle, in this case PQ is parallel to BC, it divides the other two sides proportionally. So in examination of this theorem, it simply states that if PQ is parallel to BC, then AP, as we can see, over PB is equal to AQ over QC. So it divides the other two sides proportionally. We can also look at AP and take it over the entire side called AB. If we had to do that, we could state that AP, which is indicated in blue, over AB would be equal to AQ, which I have written down, over the entire side AC. So what we're looking for here, the key point is we're looking for a triangle and we're looking for a line parallel to the third side, I will call this. And if we see these parallel lines, then we know that the ratios are in proportion. Notice that the theorem does not give you any conclusion regarding PQ over BC. But from similarity, you would be able to show that the small triangle is similar to the big triangle, and thereby we will be able to make a conclusion regarding the ratio PQ over BC from similar triangles. But we'll look at that in another video. So let's look at our first question from a past paper. It says in the diagram we have a triangle KLM, and they tell you that DE is parallel to LM. Immediately you're seeing a triangle, and when you see parallel lines, that means that gives you permission to use the proportional intercept theorem. And quickly, if I had to look at it, I can tell you that KD over DL has to be equal to KE over EM. But let's carry on reading. It gives us as LDM is equal to MDE. That's marked for us, X and X. It also shows us that KD is 9. It's in the diagram. EM is 8. And EK is 6. So our first question here is to find LM. Now LM, if you look at it, we don't have much information to work out LM. So I'm going to start with ratio and proportion. From ratio and proportion, I know that KD over LD would be equal to KE over EM. So we're going to put that down in terms of the given sides. We can now say that KD is 9. So in other words, 9 over LD has to be equal to 6 over 8. 9 over LD is equal to 6 over 8, and that's because of our proportional intercept theorem. From there, we can cross multiply. 6LD is equal to 9 times 8, and then we can divide by the 6, and that gives us LD to be 12. Now, if we actually find LD, you'll notice that I've marked these two sides to be equal, and that's simply because if this angle is equal to X, the angle at D, and because the lines are parallel, it indicates that this angle will also be X, alternate angles. And you'll notice that angle D that I'm marking now, let's call it D1, is also equal to X, which now gives you an isosceles triangle. And therefore we can conclude that LM is actually equal to 12. And you can see I first stated LMD is equal to X, and that's because of alternate angles. DM is parallel to LM, and from there I can conclude that LM is equal to LD, which is equal to 12. And please note, in grade 12 we will not accept isosceles triangle, but we will write angles opposite equal sides. Okay, so we're going to use that reason instead of isosceles triangle. And if you want to go on, you could have concluded that DL is equal to LM because of angles opposite equal sides. Okay, we're going to move on to a little bit of a more interesting question, I would say. And if we look at this question, it states that in the figure, GB is parallel to FC. And it's indicated for us in the diagram. GB is this entire line, is parallel to FC. And it goes on to tell us that BE is parallel to CD. BE is parallel to CD. AC is given to be 6. The entire side is 6. And it gives us a ratio of AB over BC is actually equal to 2. Now 2 as a fraction would be 2 over 1. We're going to get into the question. It says find AH over ED. So where am I going to start? So I'm going to start by filling in some very important information. And you must be wondering at this stage, how did I get those measurements? Now remember, if AC is equal to 6, and the ratio for AB is to BC is a ratio of 2 is to 1, so we can take our 6, and in total, the total parts from 2R to 1R gives you 3. So we can take 6 divided by 6 divided by 3, because in total we have 3 parts, and that gives me 2. And because the ratio is 2 over 1, AB will get 2 times 2, giving you the 4, and BC is 1 times 2, giving you 2. So in other words, all I've done was take the 6, divided it by 3, gives me 2, and then split the proportions according to 2:1. So going on with the question, I now can make a conclusion that AH over HE is also a 2:1. Now how did I get that? So if you look at the blue triangle, and you'll notice that these two lines, HB is parallel to EC, which allows you to say that AH over HE, and I'm going to write that down if you're a little confused. We're looking at this breaking point sitting right there, and that's the two parallel lines that I'm using if you missed that. So we know the ratio of AB is to BC is 2:1. Therefore, we can make a conclusion that AH over HE has to also be equal to a 2 over 1. And that is because HB is parallel to EC and prop int theorem. Now, in terms of, remember, we are not saying that AH is 2. We're saying that AH over HE is a 2:1. So therefore, in terms of side, I'm going to call it 2x and 1x. Now, we go on to look at the next triangle there. So if we look at now the big triangle, I've deleted all the other stuff I put there. If you now look at the big triangle, and there's our parallel lines being marked here, we can now make a conclusion, and there's our breaking points we're looking at. We can now make a conclusion that AH, sorry, I should be saying AE, looking at this to be my breaking point, that AE over ED is actually equal to, and same, it's in the same ratio, which is a 2 over 2, which is 2:1. And that's also from our reason there would be EB is parallel to DC, and you would say prop int theorem, okay? But we know, if we look at the diagram, AE is 3x. So we could say 3x over ED is actually equal to 2 over 1, which is 2. Or we'll write it there. and by cross multiplication to get 2ed, ed times 2 is 2ed, 3x times 1 is 3x, and that gives us ed to be equal to, dividing both sides by 2, we'll get 3 over 2x. And 3 over 2 is actually 1.5. So in conclusion, to answer the question, remember the question is, what is AH is to ED? So if we look at AH over ED and work with our x component, AH is 2x, and over ED, which is 1.5x, and then using your calculator you can simplify, or you could have used 3 over 2, and that will give you a ratio of 4 over 3, and that's translate to a ratio of 4:3. I hope that makes sense to you. So moving on, we've answered the first question, and then the next question, which I want to now erase, talks about looking at a ratio of BE over CD. I'm going to erase this. Okay, now we want to find out what is BE over CD. So BE over CD is actually equal to AE over the entire side called AD. And you must be, how will I know that? Because in actual fact, the small triangle here, we're looking at triangle AEB, is similar to the big triangle ADC. And you can prove that, but you don't need to do that in grade 12. It is assumed whenever you have a case from a ratio and proportion context that these two triangles will be similar, but I can prove it to you very quickly. A is common. There we have our corresponding angles with the ticks, and then we have the remaining angles, which will be some angles, or we could say corresponding there as well. So those two triangles are similar. So I could conclude that BE over CD is equal to AE over the entire side called AD, and I'm using similar triangles. And from here we can now replace the values, that BE over CD will actually be equal to AE, and if we look at the AE ratio, that is AE is 3x over AD, and AD is 4.5x. And now we can simplify that with our calculator, or we could actually use, instead of using 4.5, we could have used 9 over 2, whichever one you feel comfortable with. But very simply, because we have the calculator with us, 3 divided by 4.5 will give you a simplified ratio of 2 over 3. And that's how we'd be able to get BE over CD. You could have also used here, as I told you, 3 over 9 over 2, which is the same as 4.5, and that will give you, we're going to invert and multiply 3 times 2 over 9, which gives you 6 over 9, and that works out to be 2 over 3. There we have our ratio. The last question is simply on substitution, and they tell you HE is equal to 2. If HE is equal to 2, they are telling you x is 2. Now, if HE is equal to 2, then the 2x becomes 4, and the bottom, which is ED 1.5, times 2 would give us 3. And then we can find out what is AD. Your total length of AD would give you now 479 multiplied by HE, and HE from the diagram is 2. That will give us a total of 18. Okay, we're going to go to another question. It says in the diagram, PR is 41. We have put that in the diagram. PT is 28. It's in the diagram. TQ is 14. And immediately we see a key point, ST. ST is parallel to RP. So we can stop and say we now have permission to use ratio and proportion. In other words, that QT over TP is equal to TQS over SR. The first question there is to find the length of SQ. Now immediately if I want to find SQ, notice I don't even have SR. So I need to do a little bit of work to see how can I find SR. But a key point they are telling us here is that S1 is equal to S2. So if S1 is equal to S2, remember that's given, immediately we can conclude that P2 is equal to S2. And that's our alternate angles because TS is parallel to PR. From there, we can now conclude that SR is equal to PR. And the reason why SR will be equal to PR, we have sides opposite equal angles. In other words, we are seeing an isosceles triangle. So we can conclude now that SR is equal to PR, which is 41. So from there, we now can implement. Remember, our question is to find SQ. So I'm going to start with SQ over SR, which is 41, is equal to QT, which is 14, over TP, which is 28. And your reason there that you need to write down is prop in theorem, ST is parallel to PR. And then we're going to cross multiply. We'll get SQ times 28. 28 SQ is equal to 14 times 41. And then we're going to divide both sides by 28. And if we do that using our calculator, we're going to get 14 times 41. And then we're going to take that and we're going to divide that by 28. And that gives me SQ to be 20.5. And I'm going to put it into the diagram. And then the next question is to find ST. And I think I showed you that ST over PR, which is 41, will actually be equal to 14, that's QT, over the entire side, QP, which is 42. And the reason for that is similar triangles, all right? That means triangle QTS is similar to triangle QPR. Sorry about that. My pen is going a little bit off a tangent here. And we said QTS and QPR. Okay, and the reason for that as well is that we have ST is parallel to PR. And then we can cross multiply, and from there we can find ST. Using our calculators, we're going to take 14 times 41 and divide that by 42. And that'll give us about 13.67. Okay, we're moving on to the next question, which is quite interesting. Okay, we're looking at this question, which tells us that triangle AD, we see parallel lines, and the first one is that we have BC parallel to ED, which is on the diagram. We also have AE parallel to GF, which is also on the diagram. Then they give us some ratios. The ratio that we are given first is that AB is to BE, and we have a ratio sitting as 1R is to BE, which is a 3R. So we have a 1:3. AC is 3 units. And then we have EF is also given to be 6 units. FD is 3 units. It's all in the diagram. And they tell us that CG is X. So our first question here is to find out what is the length of CD. So I'm going to look into the diagram. To find CD, I'm going to use a triangle that I'm going to highlight. And that's the yellow one. And using that to be my parallel sides. So once again, the question wants us to find the length of CD. And if we look at the yellow highlight, using proportional intercept theorem, I'm going to take CD. So we're going to say CD over AC, which is 3, is actually equal to 3R over 1R, which is basically 3 over 1. And the reason for that, we would say, is prop theorem. And remember, we must also tell them which two lines are parallel. So we will indicate BC is parallel to ED. There we've taken that. And then by cross multiplication, we will come out with CD to be 9. And we can put into our diagram that CD is 9 units. Okay, moving on. The next question wants us to find the value of X. Now, if we inspect the diagram, I'm going to use my eraser first just to clear some space for us. And if I look at X, X is actually part of CD. So the sides I want to look at is, if we're looking at this diagram, we can look at DG over GA. So I'm going to quickly take out the highlighter and now highlight a different triangle for you that you'll be able to see it. It's the same triangle, but now I'm going to look at GF is parallel to AE. So if GF is parallel to AE, we can say that DG over the entire side, I'm going to quickly put that down for you. Actually, let me write it down first. DG over AG should be equal to, we took DG over AG, so on the other side we're going to take DF over FE, and that is 3 over 6. And once again, prop int theorem, but this time we're going to use the lines called GF is parallel to AE. Now, from this, we can establish that DG, now if we go into the diagram, and we're going to indicate this, DG, the whole of DC is 9, and we know CG is X, therefore DG should be 9 minus X. So I'm going to use 9 minus X over AG, and if we look at AG, just to clear this out, a lot happening here, so I just want to take out some things here. And if we look at AG, that's actually 3 plus x, which is equal to 3 over 6. We could simplify that to be 1 over 2. And by cross multiplication, 3 plus x times 1 is 3 plus x. And then we're going to multiply the 2 by the 9 minus x, which will give me 18 minus 2x using distributive law. Bringing my x's on one side, I will get x plus 2x is equal to 18 minus 3, giving me 3x is equal to 15. And then we're going to divide both sides by 3, and we come out with x to be 5. And that was a question to find out the value of x. And now we're going to put that into the diagram. And it might help us with the next question. So we just found out that x is 5, therefore GD should be 4. We're now going to go to the next question, which tells us to find the length of BC. Okay, I'm just going to create some space here. So we're now looking for the length of BC. Okay, and if I look at BC, and you'll remember this with the previous questions that we've done. Let me quickly highlight that, what I want to focus on. So looking at the yellow triangle and looking at BC being parallel to ED, and we can use similar triangles to state that BC over ED, and that should be equal to, so we took BC over ED, which will be equal to AB over AE. Or we could have used AC over AD. Now you'll notice if you look at your diagram, we have AC and AD, so it would be better for us to use AC over AD. And that is because of similar triangles, okay? Those two triangles are similar, and BC is actually parallel to ED. You can state which triangles are similar. So if we go back, we're going to go now into BC, looking at our diagram. So we know BC over ED. If we look at ED, we have a total of 6 plus 3 giving us 9. We could put that over 9. Then if we look at AC on the diagram, AC is 3. And if we look at AD, this whole thing here, which will give us 9 plus 3, we have a 9 plus a 3 giving us 12. And then we can cross multiply. We will end up with 12 BC is equal to 27. And then we're going to divide by 12. And that will give us BC to be equal to 12 going to 27 2 times. Remainder 3 over 12. Simplified 1 over 4 or 2,25. And that is the value of BC. Okay, we're going to create some space again. Remember, we found BC to be 2.25. And that will be important for us to actually put into the diagram. So I'm going to create some space here as well. I think we have our measurements that we want to use for this question. And we come to the last question here, which says, before we go on, we found BC to be 2.25. So we come to our last question, which it tells us to find the value of the area of ABC over the area of GFD. So we're going to write that down. We want to know what is the area of triangle ABC over the area. So they actually want the ratio GFD. So what are we going to do if we look at triangle ABC? Let's start there. And I'm going to highlight the triangle. So that's not a right angle triangle, so we're going to use the area rule. So and I'm going to keep the top in yellow so you can see that. So if we had to work that out, it will be half, and using angle, we're going to use angle A as our marker. Actually, we won't use angle C. When I look into the diagram properly, we actually have two sides in the triangle. So we have 3 and we got 2.25. So the angle we're going to use is angle C. So we can say that half, using the area rule, is half 3 times 2.25 sine of angle C. And then that is, we're going to take that, and now we're going to look at the bottom triangle, which is GFD, and I want to highlight that. So we're looking at GFD. And in that triangle, you'll notice that we have 4 and we have 3. So the angle we're going to use with the area rule is angle D. So that's actually equal to the area of the blue triangle is half 4 by 3 times sine of angle D. Now what is amazing in this question for you to note that actually angle C is equal to angle D because of corresponding angles. So we can make a note there. And now say that half of 3 times 2.25, and remember what I'm saying is that angle C is equal to angle D, corresponding angles. So we can replace D with C, or replace the top with D. But basically what we're doing is that's cancelling off. And we have to tell the marker, whoever is marking your paper, and give them a reason, which I'm going to write in the bottom, that angle C is equal to, sorry, I think we skipped something there. Let's get back. I went a little bit too far. We're going to return now. Sorry about that. I just want to get back to that. Okay, we were concluding there that angle C has got, my pen is jumping a little, that angle C is actually equal to D, and our reason there would be corresponding angles, and the lines that are parallel is BC is parallel to ED. And then from there we can work this out with a calculator. Half times 3 times 2.25 and divide that by half times 4 times 3, as we've cancelled that off, and that will give us our final answer we're looking for with a calculator. And I'm typing that on my calculator as I speak to you, and that gives me 9/16, and you can verify that. That's quite interesting how we actually worked out this question. Thank you.